Hello again. In this lecture I will give some indoor environmental related information about the virus SARS-CoV-2 that has ruled our lives for over a year now. So what do we know? We know that respiratory infections are caused by pathogens exhaled through the nose or mouth of an infected person. The pathogen, the coronavirus in this case, is aerosolized from sites in the respiratory tract during breathing, speaking, singing, shouting, sneezing and coughing, forming so-called respiratory droplets. The coronavirus is therefore not naked, but encapsulated in water-based particles, containing water, salt, protein and other components that are part of respiratory secretions and saliva. While these particles or respiratory droplets have a wide size range, most of them lie within the range from submicrometers to a few microns. The coronavirus itself has a size of around 120 nanometer or 0.12 micron in diameter. When exhaled, droplets can spread into the environment, depending on their size. The blue particles shown in this figure are larger droplets that typically have a diameter larger than 100 microns, which fall to the floor under gravity within 2 meters of the source. The red particles are small droplets, also named aerosols, typically smaller than 100 microns, can stay suspended for a longer time. How long and how far a droplet can stay or travel in the air depends on the droplet size and on the local airflow conditions, like air velocity, temperature and humidity. In still air, particles of different sizes have different settling times. Based on the Stokes law, calculations show that in still indoor air, exhaled particles of a diameter between 5 and 10 micron take 8 to 30 minutes to fall to the floor from a height of 1.5 meter, under the influence of gravity, while particles with a diameter of around 50 micron will take about 20 seconds to settle from a height of 1.5 meter. So in still air, droplets smaller than 10 micron can remain suspended in air for many minutes. But the indoor air is not still. The distance a droplet theoretically can travel is shown here for low indoor air velocities, 5 cm per second. As you can see, a particle of the size of 5 micron can, in theory, travel up to 100 meters with low air velocities, while a particle of 10 micron reaches circa 25 meters. With high indoor air velocities, 20 cm per second, these distances can be a factor 4 further. Another aspect that can affect the travel of a droplet is the humidity of the indoor environment in which the droplet is traveling. As soon as a droplet is expired, the water part will start evaporating. How much will evaporate depends on the relative humidity and the temperature of the indoor environment, as well as the chemical composition of the droplet. In this figure, an example is shown of a droplet with a size of 10 micron, containing physiological levels of salt and protein, and its size after evaporation. It has shrunk to 40% of its original size, 4 microns. For comparison, the CFD simulation shows you what happens with a droplet when a person exhales in air with a relative humidity of 35%, which can be considered dry air, and in air with a high relative humidity, 95%. In the dry air, the exhaled droplets will evaporate rapidly and continue as airborne droplet nuclei, aerosols, whereas in the humid air they will fall to the ground as droplets. Now, what are the best environmental conditions for SARS-CoV-2 to stay alive? Studies have shown that the coronavirus is quite resistant to normal indoor conditions. It seems susceptible only to a relative humidity higher than 80% and an air temperature above 30 degrees Celsius, which are unacceptable conditions when it comes to thermal comfort or risks for microbial growth indoors. SARS-CoV-2 has been found viable for 14 days at 4 degrees, for a day at 37 degrees, and for 30 minutes at 56 degrees. And at an indoor temperature of 21 to 23 degrees and a relative humidity of 65%, the coronavirus was found to be highly stable. Therefore, we conclude that humidification does not seem to reduce the viability. On the other hand, UV light from the sun seems very effective at deactivating the virus, especially at high intensities. The virus has a half-life of about 1 hour at 21 degrees and 40% relative humidity to only 10 minutes when exposed to a UV index of 2, and only 2 minutes under intense full sun, which equals a UV index of 10. Now, how is the virus transmitted? SARS-CoV-2 can be transmitted through direct or close contact with an infected person, through indirect contact via deposited or transmitted infectious droplets via surfaces such as a ball here, these are also named vomites, or through so-called airborne transmission, in which virus-carrying droplets produced by coughing, sneezing, talking, and even breathing are transmitted via the air, including both large droplets and aerosols. So, when in close vicinity of an infectious person, this whole range has the potential to be transmitted, while when further away, the virus can be transmitted only by aerosols. This means that aerosols can be transmitted both by inhalation at short and at long range. To summarize this lecture, from latest studies on indoor transmission of the coronavirus, it is clear that the source of pathogens determine the loading of the air with infectious aerosols. The thermofluid dynamic conditions of the environment, temperature, humidity, and airflow velocity, are important for the lifetime and pathway of droplets and aerosols. And airborne transmission can happen both at short and long range. Thank you for your attention.